Hey everyone, welcome back to another video by Camroom 5. In today's video, we are going to be solving the O-level chemistry specimen examination from 2023. So let's begin. The first question, like always, is some compounds are given and we have to answer by picking compounds or elements from the list. So choose from the list of oxides to answer the questions. Let's see. Each oxide can be used once, more than once, or not at all. Identify which oxide has a giant covalent structure. So we know giant covalent structure is something that has many strong covalent bonds. Now if we want a compound with many strong covalent bonds, it should not be ionic obviously. So calcium oxide is ionic. Carbon dioxide, we know that it's a simple covalent compound. Copper oxide, copper 2 oxide is again ionic. But silicon 4 oxide SiO2 is a giant covalent compound. So SiO2, also known as silica, is a giant covalent compound with high melting point. I'll be annotating my answers for some extra information also. So it's a high melting and boiling point compound. Reacts with acids and with alkalis. Now this means the compound is amphoteric. Amphoteric oxides are the ones which react with acids and alkalis both. So we need to go back and see. We have only two amphoteric amphoteric oxides that we generally go for. First is aluminium oxide and the other is zinc oxide. I can't find aluminium oxide over here, but I can clearly see zinc oxide. So zinc oxide is the answer for part B. Is used in flue gas desulfurization. Now flue gas desulfurization means that something that eliminates sulfur dioxide gas from the industrial waste. Industrial waste produces a lot of acidic oxides like sulfur dioxide and nitrogen dioxide. In order to protect the environment, we have to perform the flue gas desulfurization and we have to remove sulfur dioxide. If you remember, sulfur dioxide is an acidic compound, and in order to remove some acidic compound, we need a basic compound. Which one is a basic oxide over here, but not basic enough to cause high pH? So something that can neutralize sulfur dioxide is gonna be the first one, calcium oxide. Calcium oxide is a very good compound because it is insoluble in water. It will eliminate the acidic sulfur dioxide, but it will not increase the pH too high. Contains a cation with charge of +1. So charge of +1 means it's group 1 metal, or generally it is silver. I can't find silver oxide, but I can definitely see group 1 sodium oxide. So it is going to be sodium oxide, which is this compound. So we can write the names over here. I have written the formula. You should write the names, by the way. Moving on. Atoms and ions contain proton, neutron, and electrons. Complete table 2.1. So what is the relative mass of protons? So protons are given a relative mass of 1. Neutrons have 0 charge on them. And when we talk about electrons, so electrons are very small in size. Electrons have a relative mass of almost 0.0005. And the relative charge is -1. Table 2.2 shows some information about 6 particles. We have been given their proton numbers, which is also known as atomic number. We have been given their neutron number and their number of electrons. Deduce the nucleon number of particle A. Now nucleon number means that the number of proton plus neutron. So let's go for 37 plus 48. So 37 plus 48. It is going to be 85. Explain why particle B is a negative ion. So when we look at particle B, we can see the electrons are more than the number of protons, and electrons carry the negative charge. So there are more electrons than protons. And obviously, we don't have to mention this, but we can say that protons cancel the electrons, but there are more electrons than can be cancelled by protons. Because when electrons are more, the protons are not enough to cancel their charge, and that is why you see some negative charge. Identify two atoms that are isotopes of the same element. Isotope means same proton number but different neutron number. So same proton number is C, D, and E, but I have to find two atoms. So I have to make sure that electron and proton are same. I do not want a charge, because if there's an electronic charge on them, they won't be called atoms, right? Atoms have to have same electron and proton. Otherwise, they would be ions. So out of C, D, and E, I can see that the electrons are same in C for cat and E for elephant. So C and E are my answer. D is an ion. So D can't be an atom. D is an ion, so it's not an atom. Explain your answer. So we would say that they have same protons but different neutrons, or same atomic number but different nucleon number. So they have same proton number but different neutron number. Same proton number but different neutron number, and that should justify our 1 mark. Salts can be prepared by the reaction of acids with bases or alkalis, and also by precipitation reactions. By the way, while we are here, we should understand that acid is anything that donates hydrogen ions. Bases are anything which accepts hydrogen ions. Alkalis are anything, alkalis is a type of base, they accept hydrogen ion, no doubt. Or you can say they donate OH minus ions. Now state the ionic equation for the reaction between acid and alkali. So acids giving me H plus ion, alkalis are giving me OH minus ion. When they both react, they give me water. The ions were in aqueous state of matter. The water I get is in liquid state of matter. Sodium sulfate is a soluble salt prepared by titration method using an acid and an alkali. Identify the acid and the alkali to prepare sodium sulfate. So the acid comes from this negative ion. Acid is the sulfuric acid, and the alkali, which gives me the metallic part, is none other than the alkali sodium hydroxide. Moving on. Aqueous sodium sulfate is used to prepare barium sulfate in a precipitation reaction. In an experiment, 20.0 centimeter cube of 0.550 mole per decimeter cube of barium nitrate is added to an excess of sodium sulfate. It means that sodium sulfate is the excess reactant, so the product does not depend on this, but obviously sodium sulfate is my barium nitrate is my limiting reactant, and limiting reactant defines how much product will I get. So sodium sulfate is excess reactant, barium nitrate is limiting reactant. State the color of the precipitate formed in this reaction. It is obviously a simple white precipitate, because only transition metal compounds are colored. Only transition metal compounds and group 17 PPT are colored. This is a general rule. There are exceptions definitely, but barium nitrate, barium is not group 17, barium is not you can say transition, so it's white. Calculate maximum mass of barium sulfate. We have the equation with us. Now you should know one thing, that how much barium nitrate was given. The number of moles of barium nitrate is equals to the volume times the concentration, and volume should be in decimeter cube, so divide by 1000. I can find the moles of barium nitrate with a 0.011 mole barium nitrate. Now I know one thing, that 1 mole of barium ions give me 1 mole of barium sulfate. So same moles should be here. Moles of barium sulfate should also be the same, which is 0.011 mole. Now how do I find the mass? The mass of barium sulfate is equals to the moles of barium sulfate times its molecular mass. So molecular mass can be found by barium plus sulfur plus 4 times oxygen. When I find the molecular mass, it turns out to be 233 units. So 0.011 times 233 gets me the answer, which is 2.56 grams. A mass of 1.92 gram of barium sulfate is 1.92 grams of barium sulfate is obtained. Calculate the percentage yield. So percentage yield is equals to your actual yield or your actual mass obtained divided by theoretically predicted mass times 100. I'm actually getting 1.92 grams, but I had predicted by my calculation 2.56 grams times 100. When I solve this, my answer is going to be 74.9%. Now moving on. Calcium chloride is an ionic compound. Deduce the electronic configuration for each of the ions in calcium chloride. So calcium ion is calcium has a +2 charge and its atomic number is 20, which means there are 18 total electrons. When I write the configuration, it turns out to be 2,8,8. When I talk about chloride, chloride ions have -1 charge and their atomic number is 17, which means again 18 total electrons. So again 2,8,8. When molten calcium chloride is electrolyzed with inert electrodes, calcium and chlorine are formed. Construct ionic equations for the first two electrode reactions. Negative electrode, which is also known as cathode, attracts cations, which means calcium will be going here. When calcium goes here, which was in the liquid state, calcium ions with +2 charge will gain 2 electrons and become molten calcium metal. Reaction at positive electrode. So at positive electrode, which is also known as anode, the anions are attracted. The anions attracted over here. So chloride ions will go over here, which were in the liquid state. They will lose their 1 electron and they will become chlorine gas. We should realize that in order to get Cl2, we need double chloride ions, so double electrons will be lost and we will get 1 mole of chlorine gas. The electrolysis of concentrated aqueous sodium chloride with inert electrodes is similar to that of concentrated aqueous sodium chloride. Predict the products of the electrolysis of concentrated aqueous calcium chloride. We should understand that here we have 4 ions. In calcium chloride in the aqueous state, not only do we have calcium ions and chloride ions, but we also have H+ ions and OH- ions. Out of calcium and hydrogen ions, hydrogen will be discharged because hydrogen ions are lower in the electrochemical series. And when hydrogen ions are discharged, the first product that we receive is hydrogen gas. Hydrogen gas, H2 gas, is the first product that we receive. When we talk about the competition between chloride and OH, we should realize that this is a concentrated solution, right? In concentrated, chloride ions will be discharged. And when chloride ions are discharged, we get chlorine gas, Cl2. So chlorine and hydrogen should be our product, while calcium ions in the aqueous state and hydroxide ions in the aqueous state will stay in the solution. They will remain still in the solution. Calcium chloride has a higher melting point. Explain why calcium chloride has a high melting point using ideas about structure and bonding. So when we say structure, what kind of structure can we think of in calcium chloride? So it is giant ionic lattice. calcium chloride is a giant ionic lattice because there's going to be, let me show you, there's going to be so many calcium ions like these, and there's also going to be so many chloride ions like these. Each calcium ion has +2 charge and each chloride with a -1, and obviously we'll balance it somehow, but we don't have to worry about it. The point is it's a giant ionic lattice and there is some kind of bonding going on. What's the bonding? It's a strong electrostatic attraction between all the positive and negative ions. So you will say strong electrostatic attractions between the positive and negative ions which require high heat energy to be overcome, right? This is the basic idea behind calcium chloride. The question 5 says, figure 5.1 shows the alcohols ethanol and butane-1-ol. By the way, you should realize that butane-1-ol means that it's the actual scientific name based on the numbering of carbon atoms. Let's say this is carbon. Okay, I'll have to set this again. Yeah, carbon 1, 2, 3, 4. And since the OH group is on carbon 1, we are calling it butane-1-ol. Describe the manufacture of ethanol from ethene. So ethene is an alkene, and in order to convert it into ethanol, the process that we go for is called addition of steam or hydration. So addition of steam, also known as hydration of steam, should be the process. Hydration of ethene, using steam. My writing is going bad. Using steam and phosphoric acid catalyst at 300 degrees Celsius. Ethanol is used as a fuel. State one other use of ethanol. So when we talk about ethanol, we can come up with a lot of uses, but we have to make sure that we have to pick something which is scientifically accurate. So generally we can go for solvents. If we say solvent, we should be talking about how it's a solvent for some compound. For example, it's a solvent in perfumes for sure. It is used as an antiseptic for sure. So generally you can say it's a solvent. I would rather suggest you to mention for perfumes. You can say it is used to make vinegar. It is used in alcoholic beverages. Construct a simple equation to show the incomplete combustion of ethanol. So when we talk about ethanol, C2H5OH, incomplete combustion means oxygen is there but it's not enough, and we end up making carbon monoxide or maybe carbon dioxide or something like that. So how about we make carbon monoxide? 2 carbons, 2 carbon monoxides. Since we have got 6 hydrogen atoms, so why don't we make 3 water molecules so that the hydrogens are balanced? And now let's talk about how much oxygen is needed. So in order to make 2 carbon monoxides, we need 2 oxygen atoms here. And in order to make 3 waters, we need 3 oxygen atoms here. That's a total of 5 oxygen atoms. Out of the 5 oxygen atoms, 1 atom is already here. So we need 4 more oxygen atoms on the left hand side. So I will add a 2 before O2. Ethanol is oxidized to form ethanoic acid. State the name of the reagent that is used for this oxidation, which means a strong oxidizing agent. What is a good, strong oxidizing agent that oxidizes ethanol? And that is none other than acidified potassium manganate. Acidified potassium manganate. And don't forget to mention the 7 afterwards. Otherwise, like oxygen is also okay, but generally I would say potassium manganate is the better choice. Draw the displaced formula for different alcohol that is isomer of butanol. So we can either make a branched alcohol or we can make a position isomer. Position isomer means that we can change the position of the functional group. So the first option I have available is making 4 carbons, but instead of making the OH on the carbon number 1, I can make it on carbon number 2, and the rest of the carbons have their hydrogens like normally, like this. That would be called butane 2-ol. Another possibility is I make the compound branched. Instead of having 4 carbons, I can make it branched like this, and I can put the OH on carbon 1. In this way, what I'm going to get is a branched alcohol which has total 4 carbons, but you will notice that the name is going to be, based on numbering, the name is going to be 2-methyl, because there's a methyl group on carbon number 2, so 2-methyl propane 1-ol. And the name for the first compound was simply butane 2-ol. Butane 1-ol is heated with concentrated sulfuric acid which acts as a catalyst. Butanene and one other compound are formed. Draw the structural formula of butanene. So we need to draw 4 carbons like this, and there will be a double bond between carbon 1 and 2. This is carbon 1, 2, 3, 4. Now on carbon 1 we have space for 2 more hydrogens. On carbon 2 we have space for only 1 hydrogen. Carbon 3 has 2 more hydrogens, and carbon 4 can make room for 3 more hydrogens. That's butanene. Deduce the other compound from this reaction. So if you notice, butanol, which was a chemical formula of C4H9OH, if it reacts in the presence of concentrated sulfuric acid and gets you butene, butene has a formula of C4H8. Now what's the other compound? If you count, there are 4 carbon atoms over here, there is 10 hydrogen atoms over here, and there is 1 oxygen atom over here. In butanene we have 4 carbon atoms, so we don't need more carbon. All the carbons from butanol goes into butene. We had 10 hydrogens in butanol, but we have only 8 hydrogens over here. So 8 hydrogens in butene. What about the other 2? So we need 2 hydrogens in the other compound and 1 oxygen in the other compound. Which molecule do we get? So we get H2O. So we get H2O, and this reaction is basically known as elimination, or you can call it dehydration. So water is the other compound we get, and this reaction is also known as elimination or dehydration reaction. Butene is polymerized to give polybutene. State the type of polymerization. So polymerization for alkene is always addition, because they can perform addition reactions. Draw the structure of polybutene showing at least 1 repeat unit. So let's go for making the polymer. In order to understand how these things are working, we first need to draw butene. Butene means that there's a carbon-carbon double bond between carbon 2 and 3, and the other carbon atoms have their hydrogens based on valency. See, this is your butene, carbon 1, 2, 3, 4. There's a double bond between carbon 2 and 3. Now we need to understand that main focus should be these 2 carbons. The carbon number 1 is here, like I should say carbon 2 is here, carbon 3 is here. This is carbon 2, this is carbon 3. What's on carbon number 2? So on carbon number 2, there's 1 hydrogen at the bottom, and there's a CH3 group like this. So there is a CH3 group on carbon 2, which I draw like this. I can change the angle, that's totally okay. What's on carbon 3? On carbon 3, I have a hydrogen, so I put a hydrogen at the bottom, And on carbon 3, I have again a CH3 unit, which was on the right hand side. Now I am drawing it on the top. This is but-2-enes monomer without the double bond. See, I have not drawn the double bond over here. The double bond is gone. The double bond is gone between carbon 2 and carbon 3. Everything else is the same. This is your repeat unit. You can make this another by copying this structure like this. You can make 2 monomer repeat units like this, and this is your polymer. This is your first unit, and this would be your second unit, and there are so many units that can go on.